Now we will see the next problem. If the value of universal gravitational constant in SI unit is 6.6 into 10 to the power minus 11 Newton meter square kg minus 2, then find its value in CGS units. Previously we have seen from CGS units they have asked us to convert to SI units. In this problem the value is given in SI units, they have asked us to convert into CGS units, that is 2 centimeter gram and second. Similarly, similar pattern has to be followed. Okay, here the value to be converted is a gravitational constant. So gravitation constant, we have a constant value, so this problem will be comparatively very easy. Now gravitational constant in SI unit, that is GSI, means gravitational constant value in SI unit is 6.6 into 10 to the power minus 11 Newton meter square kg to the power minus 2. Now we have to find the gravitational constant in CGS units. Now using the same method, okay, in the previous problem we have taken the previous problem we have taken the value that is already given is CGS units, so we have taken as P1, so M1, L1 and T1. The value that is to be found out is taken as P2. Similarly here we have to take the value to be found out here is taken as N2. Okay, now see the formula here. Now the CGS units, G CGS is equal to, okay, G of SI into M1 by M2 to the power A, L1 by L2 to the power B, T1 by T2 to the power C. It is just similar to what we have done here. It is just similar to what we, instead of P1 and P2 they have put GCGS, here instead of P1 they have put GSI units. Okay. Now all this formula remains the same. Now we know that the value that is already given to us is in SI unit, that is mass is equal to 1 kg and L1 is equal to 1 meter and T1 is equal to 1 second. Okay. Now M2 is equal to, we have to convert it into CGS units, centimeter, okay, that is centimeter, gram, second, CGS units. Now you may be wondering how this value of A equal to 1 and B equal to 3 and C equal to minus 2 came. So we have to know the formula of, that is the units of the gravitational constant. Only then you will be able to solve it. So for that, see the previous page, the page number 31, we have, see this, gravitational constant value. Gravitational constant is equal to force into distance, the whole square divided by mass square. What is the unit? See, m to the power minus 1, L to the L cube, T to the power minus 2. See the value here. Okay. So we are writing m value, that is m value we are writing as m value here we have m value minus 1, m value here we have, for gravitational constant we have minus 1. So that is A we have mass, that is m is mass. Okay. Similarly B equal to 3. See here, length is equal to 3. For gravitational constant L is equal to L cube. Okay, that is B. We are writing as B, that is gravitational constant, that is length. Okay. Similarly here T equal to minus 2. So we are writing time is equal to minus 2, that is C equal to time. Okay, time, that is minus 2. Now students, kindly ensure that you memorize all this, otherwise you will not be able to score marks in this section without memorizing this. In the examination we may not be having time to derive each and every unit. The derivation is one part, but it is better to remember or memorize these units so that we don't waste time on this. Now we know that CGS, GCGS is equal to GSI. What is the GSI unit they have given? The problem 6.6 into 10 to the power minus 11. We write it as it is. Now we have to convert that into CGS, that is 1 kg M1 Okay, M1 is kg, M2 is in gram. So kg by gram. L1 is in meter, L2 is in centimeter. Now we read as meter by centimeter. Seconds are same. Now again, as in the previous problem, we are trying to bring it into a common unit. Here see, here we have converted this gram into kilogram to bring it into a common unit. Now we have seen until this point 6.6 into 10 to the power minus 11 kg by gram, etc. Now this step is actually wrong. Now we have supposed to convert the value into CGS units, SI units into CGS units. So we have to convert this value kg into grams and meters into centimeters. Now this has not been done here. So we will see in detail about how the missing steps here. Now 6.6 into 10 to the power minus 11. This 1 kg is written as 1000 grams and 1 meter is written as 100 centimeter, etc. Now this 6.6 into 10 to the power minus 11. This 10 to the power, this 1000 is written as 10 to the power 3. This 100 centimeter is written as 10 to the power 2 into 3 to the power 3 is 10 to the power 6. Now we have gram to the power minus 1, centimeter cube, seconds minus 2. Okay. Now again we have, let us take all this 10 to the power minus 11, 10 to the power minus 3 becomes 10 to the power minus 14 into 10 to the power 6 becomes 10 to the power minus 8. Now we are left with gram to the power minus 1, centimeter cube, s to the power minus 2. Now we have to bring this into some form where we can write it as dyne. Now we know that 1 dyne is equal to 1 gram centimeter by second square. Now in order to bring this value gram to the power minus 1 centimeter cube in s to the power minus 2 into this form, we are writing gm plus 1, gram plus 1, gram minus 1, and this gram minus 1 is written as it is. Now centimeter cube is divided and written as centimeter and centimeter square. S to the power minus 2 is written when brought down and written as s square. So now we have here gram centimeter square divided by gram, not centimeter square, gram centimeter divided by s square is 1 dyne. Now this all these circled values are taken. Gram, that is gram, okay, 1 gram, 1 centimeter. This s square is written here, okay, s square is brought down. The remaining we are left with gm minus 1, gm minus 1, okay, and centimeter square. Now we are writing this value as dyne, gm minus 2, minus 1 is written as minus 2 centimeter square. Now finally we have gravitation constant g. Gravitation constant g in CGS units is equal to 6.6 into 10 to the power minus 8 dyne centimeter square into g to the power minus 2. I hope you would have understood. There is only one confusion here in this part where it should have been converted into grams, okay, CGS units, which is not done here, okay.